in this, we will now study some basic and standard signals which are useful for signal analysis, and also the operations which can be performed on a signal. Okay, we can write down that topic is basic signal. Okay. The first in this category is impulse. Actually, when we are defining this, I should say mathematically they are not signal, they are but a function. Okay, so I can define an impulse function delta t such that minus infinity to infinity delta t dt is equal to 1. Or I can write delta t equal to 1 at t equal to 0, and it is equal to 0 for t not equal to 0. Okay, that is, it has finite value at one point and 0 value elsewhere. Okay, now we look certain properties of the delta function. Minus infinity to infinity delta t dt is equal to 1. Second, ft delta t is equal to f of 0. Third one is delta of t minus t naught into ft is equal to f of t naught. This is called shifting property. Okay, remember, it is not shifting but it is shifting. Fourth one is 0 to infinity delta t dt. It is not defined. Zero minus to infinity delta t dt, it is equal to 1. Minus infinity to 0 delta t dt, it is also not defined. Okay, minus infinity to 0 plus delta t dt is equal to 1. Okay, so these are the various properties of this. One more is 0 minus to 0 plus delta t dt is also equal to 1. Okay. Second function in this is, or I can say second type of basic signal is unit step. Denoted by ut. Mathematically, ut can be written as 1 for t greater than 0, 1 by 2 for t equal to 0, and 0 for t lesser than 0. Okay, then ut is something like this. Okay. Third type of function is, third type of signal is ramp signal, denoted by RT. RT is equal to TUT, or I can write it is equal to T for T greater than 0 and is equal to 0 elsewhere. Okay. If we look at the UT once again, at t equal to 0, it is considered as 1 in most of the practical problems. Okay. In the problems, whenever if it comes, we have to treat ut equal to 1 for t equal to 0. Okay. Remember this point. Don't put 1 by 2 for t equal to 0 unless and otherwise it is stated. Okay. Now we will see the operations which we can do on a signal. Okay. There are two parameters to vary in signal. Okay. In time domain. First is the amplitude parameter. Second one is the time parameter. Okay. Now, with respect to amplitude, parameter, we can do the scaling of amplitude, we can do addition, we can do multiplication, we can do subtraction. Okay. With respect to time parameter, I can do shifting, I can do scaling, I can do time reversal. Time reversal and scaling, they both have one parameter. They both have one type of operation which we are doing. See, reversal means multiplying by minus 1. Okay. Now, which operator to be, which type of operation to be done first? It is also very important. Okay. See, if I want to shift, if I want 2t plus 3 from xt, then I should first shift t by 3, then I should scale t by 2t plus 3. So that means first is shifting, then scaling. Suppose if we are taking it other way around, suppose if I take x 2t first and then if I shift it by 3, that will become x of 2t plus 3, which is equal to x of 2t plus 6, not equal to x of 2t plus 3. Okay. Thus, we have to follow the rule that shifting, then scaling, then time reversal. operation to be done. Okay. Let's see one example. Suppose xt is okay. Then from this, if I want x of t plus 3, then I have to shift it by 3. Since it is a plus 3, that means it is shifted on the left hand side. So it becomes minus 2. Okay. Similarly, if x of t minus 3, then same thing will be shifted more towards right hand side, and this will become okay. Amplitude will not change. Amplitude here A, amplitude here A, amplitude here A. Okay. Amplitude will not change, but shifting operation will shift the signal to the right hand side or to the left hand side. I can write xt changing to x of t minus t naught. It is a positive shift. Xt changing to x of t plus t naught. It is a negative shift. Okay. Third, other operation which we can do on this is time scaling. Xt changing to x of at. Okay. A is not equal to any negative value. When a value is greater than 1, it becomes compression of signal. If a value is lesser than 1, it becomes expansion of signal. Okay. Write one note. If a unit step signal is there, ut, and if I write here scale it by kt, then ut is same as u of kt. That means time scaling has no effect on unit step signal. Okay. Another operation which we are doing on time is time reversal. Time reversal operation is nothing but shift making xt to x of minus t. Okay. When I do this, it is nothing but considering y-axis as mirror, draw xt on other side. For example, if I have signal something like this 1, 3 and 4. Okay, amplitude is 1. This is my xt. Then x of minus t will be -1, 3, 4, minus minus amplitude again will be 1 only. Understood? So this way the time shifting, time scaling and time reversal operations are done on a signal. We will solve few problems which will give us the better understanding of